to our 5th lesson of Research Done Right. In this lesson, we will be talking about measurement concepts. In lesson 4, you learned about the importance of operationally defining your variables. You learned about the different types of relationships that could exist between the variables, and you were introduced to validity. Today, we're going to talk about specific measurements that you will use when defining your variables, as well as how to measure them. So the first thing we'll talk about is reliability. When we think about the word reliable, we think that it's basically something or someone that you can depend on. When we talk about reliability in research methods, it kind of has a similar meaning. But ultimately, it's about using a method, using a measurement, a scale, a survey, a tool, a questionnaire that has been accepted to be reliable in the past. In other words, other researchers have used it and proven that it in fact is a valid source to measure your indicated variable, and therefore the measurement is reliable. We will be revisiting validity. So in the previous lesson, you learned about construct validity, internal validity, and external validity. In this lesson, we're going to focus on construct validity and learn about the different types of validity that is part of construct validity. After that, we will talk about reactivity and reactivity measures and how you should avoid those because of the negative effects that they could have on your research experiment. And the last thing we'll talk about are the different types of scales that you could use when measuring your variables. So let's start with reliability. Reliability is the consistency or stability of a measure or behavior. When we say that something or a measurement or tool is reliable, it means it will yield the same results each time the measure is administered. For example, if you have a scale in your house and you want to see how much you or something else weighs. Generally, yes, our weight could fluctuate slightly plus or minus up or down, but for the most part, every time you stand on it, it will generally give you a very similar reading of your weight. So that would mean that the scale is a reliable measure of your weight. So the question you should ask yourself, does the measurement that you are using, does it fluctuate from one reading to another? If it does fluctuate, then it means that there is an error in your device. Another example in which we see fluctuations in devices is when it comes to technology. So for example, if you ever try to measure your blood pressure with one of those home blood pressure kits, right, the electronic ones, if you were to measure your blood pressure 3 times in a row and you kept getting different readings, then it could also be an indication that the device is broken or that it's not an accurate representation of the measurement of your blood pressure. So any type of tool that you're going to use to measure your variable should be reliable. And each type of measurement has a true score. The true score is the real score on a particular variable. So again, you want to have a true score. You want to have an accurate representation of the variable that you are measuring. The measurement error would not provide an accurate indication of the given variable you are measuring. So again, if it fluctuates and it has an error in the device, that would be a measurement error. And what we should always strive for is a true score, meaning an accurate representation of whatever it is that we are measuring. So reliability is important because typically, if you think about it, when you conduct experiments, and of course there are exceptions, but typically when you're conducting experiments, you're not measuring participants more than one time. So imagine that you are ready to conduct a particular research experiment. It's quite challenging to recruit participants, to get them to show up, to go through the informed consent. You've gone through this entire process. Now you're ready to start your experiment. And you want to make sure that you get every possible bit of data that you can for your experiment. So you want to make sure that you're using a measurement that is reliable. You don't want to collect data from 50 different participants and then realize that you're using a faulty tool, right? You're using a measurement that is constantly giving you measurement error. You can't go re-ask those same 50 people to participate again once they've already participated once. So typically we only measure a participant one time. Therefore, we want to make sure that we make the most of it and we use a reliable measure. So how do we know what is a reliable measure and what is not? Well, if you remember back to lesson 2, when we talked about the importance of literature reviews and looking up previous literature, previous research, I should say, that in the methodology section of what other researchers have used is where you can find reliable measurement tools. It's totally okay to look up the methodology section from previous research and borrow the same tools that they use. In fact, that is encouraged. Of course, you definitely would want to cite where you got the tool from, but that is completely encouraged in order for us to maintain the usage of reliable forms of measurement. An unreliable measure would lead to unreliable results that can't be replicated. So again, you want to make sure that when you are choosing your measurements or your scales or what have you for your particular variables, and you write about them in your methodology section, remember, all of that information is almost like a recipe that someone else can then follow if they wanted to cook up the same experiment that you are running. So you want to make sure that the measures you're using are reliable so that if someone were to replicate your study, they would get the same results. So how can we assess reliability? Well, typically, when you look in previous research and the authors indicate a particular tool they used, in parentheses right near it, you will see a reliability measure. And this reliability measure is typically represented as a correlation coefficient. And this correlation coefficient checks for the relationship between the scores on the items among several participants. So in other words, let's say I have 10 different participants who took the same survey and they were in the same condition of the independent variable. We typically would look at how their scores of those 10 people correlate with each other. If they are strongly correlated, it would show that your measure is reliable. If the people were generally supposed to be very homogeneous and similar, and you realize that their results are all over the place, that would indicate that there's something wrong with your measurement tool. There's something wrong with that particular survey. So the coefficient can never be greater than +1, because as we learned in our previous lesson, the maximum correlation between two things that you can have is 100%. And if we convert 100% into a decimal, we have a whole of 1.00. So if I wanted to look at what scores did participants 10 through 50 obtain for questions 1, 5, 9, and 13, using something like a random item analysis, if their scores correlate on these 4 different questions, then that would indicate that the measurement I'm using is reliable. If the correlation coefficient is very, very low, it would indicate that the results are not similar and that your tool is not reliable. Another way to assess reliability is using the test-retest reliability measure. So in this case, you're testing the same individuals, you're measuring the same individuals at 2 points in time. If their responses are correlated, that's another good indication that your measure is reliable. The third type of test we have is the internal consistency reliability, or another word for this is the split half reliability. In this case, a researcher would randomly select certain items from the first half of the measure, and then randomly select some items from the second half of the measure, and compare them. So if the responses between the randomly selected first half and the randomly selected second half are similar, or they're correlated, that's another indication that your measure is reliable. In other words, if the items are truly measuring the same variable, then they will be correlated. So again, the way we assess reliability is through correlation, and the closer that correlation is to +1, the more reliable your measurement is. I'm telling you all of this not with hopes that you create your own form of measurement. I'm telling you this so that when you are doing your literature review and looking at previous literature and you see R equals next to some form of tool or measurement, that you understand what that is. But I highly, highly recommend, especially if this is your first research project, that you use a measurement tool that has already been established as a reliable measure for your experiment. So remember in the previous lesson, we talked about different types of methodology. One of the methodologies we talked about was experimental, but then we also talked about non-experimental methods or quasi-experimental methods. And one of those things included direct observation or field research. I gave you an example in that lesson about observing aggressive behavior in children on a playground. So when you do this, again, you don't have much experimental control, but you do have the ability to observe them in their natural setting. So when you do this, you are subjectively trying to identify whether the behaviors are aggressive or not. Given the fact that you are measuring this behavior simply by looking at it, it all depends on the researcher's perception of what he or she is seeing. Naturally, the operational definition for aggressive behavior is critical here, but you also don't want to be the only researcher making this observation because, again, as a researcher, we could be biased. And of course, our subjective perceptions can affect, the objectivity of the research. So what we often do is have inter-rater reliability. Inter-rater reliability is used for these types of subjective measurements, such as observations or judgments. And in this case, more than one person is measuring a subjective thing. Typically, we like to have an odd number of raters in order to not have the possibility of breaking even. So imagine if you have two people and one thinks it's aggressive behavior and the other person thinks it's not aggressive behavior, there needs to be a third person that can overpower and, in a sense, create a majority opinion. Same problem is if you have four people. Imagine two people say it is aggressive and two people say it isn't aggressive. Again, you're stuck in this tie position. So it's better to have an odd number of observers when you're conducting some type of observational research. And the fact that you have more than one person observing with you is another way to measure inter-rater reliability. So it's unreliable to have just one person rating the behavior. You should have at least two. And if the ratings are the same or similar, then the correlation coefficient is reported to be high. If the ratings are not the same or they are dissimilar, then the correlation coefficient, it tends to be lower. So again, this really comes back down to how you operationally define what it is that you're looking for. If you create very specific criteria and limits, for example, aggressive behavior is defined as screaming at another child, or teacher, pushing, any sort of physical behavior, using bad words, raising someone's voice, etc. And every time you observe that a child has conducted one of these behaviors, they get a point. So the more points accumulated in your observations, the more aggressive the behavior is considered. That would be an excellent way to make sure that all of the raters are on the same page as far as identifying what is aggressive and what is not aggressive. If you correctly operationally define your variables and everybody is clear in terms of what they're observing and how they are scoring it, then your correlation coefficient will be high because the ratings will be the same or similar. So reliability, again, tells us if our measures are reliable, but it doesn't tell us if the measures are good. So for example, there is a foot intelligence scale. So the idea is that the size of your foot can determine how intelligent you really are. Now, typically the size of your foot won't change once you reach a certain age. So every time you apply the foot intelligence scale to yourself, the reading on it will be consistent. It will remain the same. So it means that the measure is reliable, but how true, right? How valid is it that the size of our foot can actually predict how intelligent we are? So when you conduct your own experiments, you want to look for measures that are valid, but also reliable. In the case of the foot intelligence scale, it's reliable, but it certainly isn't valid. So just be aware of that and make sure that you're choosing measurements for your variables that are both reliable and valid. And so in terms of this type of validity, right, which of the three do we actually consider? So we have construct validity, internal validity, and external validity. When we talk about the reliability of measures, we are talking about construct validity. So, just to refresh your memory, when we previously spoke about validity, we spoke about construct validity. How well does your operational definition define what your variable really is? The second was internal validity, which told us about whether or not the dependent variable is truly caused by the independent variable and not due to some alternative explanation or confounding variable. And the third type of validity is external validity. To which extent are we able to generalize our findings beyond our sample, right, to other populations everywhere else in the world? So given those three, I want us to focus a little bit more on construct validity in particular. Construct validity, again, refers to how well you've operationally defined your variable and whether or not the way that you are planning to measure that variable is valid or not. So the first type of validity in the umbrella of construct validity is called face validity. Do the procedures reflect the operational definition of the variable? So again, face validity is subjective and intuitive, in meaning that if you, for example, are trying to operationally define the word aggression, everyone has their own perception and their own subjective definition of what the word aggression means. To some people, saying something rude is not aggressive, but, punching someone would be aggressive. And vice versa, right? Perhaps someone thinks that, even using a bad word is an example of aggressive behavior. So the degree to which we perceive the definitions of certain variables can vary. Therefore, it is subjective, and thus we call it face validity, right? How it appears. So appearance is not a good measure of accuracy, but we definitely don't want the face validity. We don't want our operational definitions to be extremely contradictory to what the general population understands this particular variable to mean. So face validity is important, but it is not a really good measure of accuracy. The second type of validity in the realm of construct validity is content validity. So you compare the content of the measure with all of the factors that define this construct. So for example, if you are measuring the knowledge of driving a car, right? You want to measure, your goal is to use knowledge of driving a car as a variable. And so you start operationally defining it, right? What type of information would you include in your measurement if you were truly trying to understand how well someone knows how to drive? So you may ask things about, traffic signals. You may ask things about road signs. You may ask things about procedure of when you want to change your lane or make a turn, right? Hopefully they would say something like, I would turn on my indicator. You probably would not ask a question like, what did you eat for breakfast this morning? So that last item seems like it totally doesn't make sense in terms of the content for understanding if someone has knowledge of driving a car. The third type of validity is called predictive validity. So research that uses a measure of some sort to predict some future behavior. So a very common one that comes to mind now is the GRE, right? The graduate record exam. And typically students who apply for grad school, they have to take as a prerequisite the graduate record exam. And the purpose behind this exam is that they feel like if you score high on the GRE, that will indicate that you will do well in grad school. Another example is the LSAT. The LSAT scores are used to predict success in law school. So that is an example of predictive validity. If the students who score high actually are the ones who do well in law school, that would mean the predictive validity is good, it's strong. However, if you have students that do poorly on the LSAT but excel in grad school, then that would be the complete opposite, and that would suggest that the predictive validity is weak or low. The fourth type of construct validity we have is called concurrent validity. Concurrent means things are happening at the same time. So with concurrent validity, we're examining the relationship between the measure and the behavior at the same time. So for example, do two or more groups of people differ on the measure in a way in which you would expect? So we often see concurrent validity occurring if we have one group experiencing one level of an independent variable and another group experiencing another level of that IV. We would want to see that their scores differ or their measurements differ in certain ways relative to the condition of the independent variable in which they are in. So if we do see these changes happening at the same time, that is an example of concurrent validity. Then we have convergent validity. I apologize that so many of these start with the letter C, but I promise I didn't make these up. And hopefully with repetition, you will be able to differentiate between them. But we also have convergent validity. Convergent validity is the extent to which the scores on a current measure correlate with scores of similar constructs. So for example, if you were measuring depression using a particular questionnaire, you would want to see if the responses from your given questionnaire correlate with other depression questionnaires, right? Are the questions that you are asking similar enough to other measures that have measured depression in the past? If they are, it would mean that you have strong convergent validity. And that's, again, a really good thing that you want to strive for. And the last type of validity we'll talk about under the umbrella of construct validity is discriminant validity. Discriminant validity is when the measure is not related to variables with which it should not be related. So going back to the idea of what questions you would ask if you actually wanted to find out if someone has knowledge of driving a car, the question about what they ate for breakfast that morning would definitely be a question that doesn't apply. So here, for example, when you're measuring academic achievement and you're using GPA as a measurement of that, GPA would have no relationship to commuting distance. So the discriminant validity here suggests that there are certain factors that should not correlate with other factors of your particular measure. When we think about academic achievement, we think about grades, we think about extracurricular activities. We typically don't think about how long it takes or how far it takes students to commute to their educational institution. So the fact that that would not correlate with their GPA is a good sign, and so that would be an example of discriminant validity. So that brings us to our topic of reactivity measures. Reactivity is something that you definitely want to avoid when you conduct your own research. Reactivity measures pertain to the fact that when we are conducting research, participants know that they are being watched and listened to and observed and evaluated. So when we think of the word reactivity, it comes from the word to react, right? To have a particular reaction. Unfortunately, when we conduct research, our goal is always to have participants act and behave as normally and naturally as possible. But you can imagine that when people know that they're being observed, they tend to behave in other ways. So reactivity is when the knowledge of being measured changes a participant's behavior. Some of these changes that we can see can include physiological responses. For example, participants can start sweating or their heart rate can increase. We can also see changes in behaviors. So these behaviors could be voluntary or involuntary, right? Some people get nervous and start maybe to blink or to shake or to engage in some, particular activity, maybe rubbing their hands together, maybe, feeling fidgety. And sometimes they know that they're going to behave in a way that they think the researcher wants them to behave. So again, they're not performing naturally and organically. And so that, of course, will affect our data and the accuracy and validity of our research. And so ultimately, any type of changes in the behavior that is different from their natural or unobserved circumstances, right? So how would they act if they weren't being observed? How would they act if they didn't know that we were watching? And so that is something to be very aware of when you are conducting your experiments. So as a researcher, your goal is to use non-reactive and unobtrusive measures. And so this typically applies much more to field research or direct observational methods than it does when you have people come into your laboratory. Because when participants are signing up to participate in an experiment, a lot of times those experiments are conducted in a room, in a lab, and there's consent that is given. And the participants are saying, yes, I'm willing to participate in your study. And of course, you as the researcher are required to tell them a little bit about what they're going to be doing. So there is this trade-off, right, between doing lab research in which you have a lot of experimental control and strong internal validity, but there's a possibility of reactivity. And on the other hand, doing something much more naturalistically observing. You're not talking to anyone. Anybody could see exactly what they were doing if they were in your same position. And so you're not bothering them. You're not asking them questions. They don't feel like they're being watched or evaluated. So you do get much more raw or natural results, but at the same time, you're sacrificing that internal validity. So typically, if you know that you're going to be conducting some type of field research, or you're trying to conduct a particular study or experiment in which you don't want the participants to know what exactly you will be measuring, or you are afraid that they will behave in an unnatural way, you really want to make sure that you think about a way to cleverly, but indirectly record and measure your particular variable. So I'm not saying to use deception. I'm not saying, to do anything unethical. I'm just saying that you probably want to think this through before you start executing your particular experiment. And so this brings us to the last topic of our discussion, scales of measurement. So if you recall, in our previous discussion of variables, we learned that variables could be measured in a qualitative, but also in a quantitative way. But when it comes to performing statistical analyses, the way that we manipulate information about variables is definitely using numbers or some numeric quantitative representation. So we do have 4 different scales of measurement. The first one is the nominal scale. So the nominal scale is used for naming variables in no particular order. So these are known as categories, right, in which you have things like eye color or hair color or height or type of pet, right? So green, blue, hazel, gray, right? Those words are nominal. They are categories. And the order, like blue is not better than gray, brown is not better than hazel, so on and so forth. The second type of scale we have is an ordinal scale. And if you think about the word ordinal, it sounds like the word order, right? So the ordinal scale is used for variables to put them or rank them in a particular order. For example, first place, second place, third place. Number 1 can be happy, number 2 can be neutral, number 3 could mean unhappy. You can also think about ratings for like a hotel or a film, right? 3-star rating is worse than a 5-star rating. So in an ordinal scale, the order in which the variables appear does matter. The third type of scale we have is the interval scale. So the interval scale is used for numerical variables with known equal intervals of the same distance. So an example of this, for example, could be time, right? A clock. Basically, interval scale means that from one point to the next point in the same measurement, you have an equal amount of intervals. So if you think of a clock, right, between 12 o'clock and 1 o'clock, we know that there are going to be 60 minutes. We also know that from 1 o'clock to 2 o'clock, we also have 60 minutes. So in other words, the clock is an example of an interval scale because there will always be 60 minutes between each hour. If you are thinking about a graph, for example, right, and you have your axes labeled in units of 2, 4, 6, 8, 10, right, the intervals increase in units of 2. So that is another example of an interval scale. The anchors, the units, but as you increase, are always going to be the same. They're going to stay equal. They're going to be 2. If you have something like 1, 3, 7, 29, 52, that's definitely not an interval scale because the difference between each point, each anchor, is not equal. So far we talked about nominal scale, which is used for categorical data. For example, yes, no questions, identification of gender, male, female, eye color, the type of pet you have, etc. Then we have ordinal scales in which the order does matter, right? First place, second place, third place. We talked about the interval scale, right? Which means that it is now numeric. It is not, it's not a categorical variable, but it's something that involves numbers, and these numbers need to escalate in equal intervals. And the last one we have is the ratio scale. So the ratio scale is ordinal, right? The order does matter. It is also interval. It means that you have equal intervals between each anchor, but it also has a true 0 point. Okay, and so that is the difference between the ratio scale and, for example, the interval scale. So the ratio scale is used for variables on a scale that have measurable intervals, including a true 0 point. So if you were trying to measure the number of chocolate chip cookies someone ate, it's entirely possible that they could have eaten 0 cookies. So again, most variables that you will be measuring are going to exist on a ratio scale, but it's entirely possible for you to have variables on a nominal scale when it comes to gender or satisfaction rating or feeling happy or sad. And so in this case, you would typically assign a number to the particular category or word. So for example, if I asked you a yes or no question, like, do you like to watch movies? And there was a yes and a no response, I would code yes as 1 and no as 2. But again, the 2 is not worse than the 1 is not worse than the 2. Basically, you're just assigning a number to a particular word. So in a nominal scale, even though the response choices are in the word format, in order to statistically analyze them, we need to code them into a numeric format. But those numbers are simply codes. They don't actually mean they don't have any value when it comes to the different answer choices, which is very different from the ordinal, interval, and ratio scales. So that concludes our lesson for today on measurement concepts. Remember, you always want to strive to get measures that are reliable. We have a variety of different ways to test for reliability, but the main piece of advice is for you to use tools that have already been proven to be reliable, and you find them by conducting your literature reviews of previous research. We also revisited validity, and we spoke specifically about construct validity, and I believe the 6 different pillars of construct validity that exist. We talked about the danger and the awareness of reactivity and using measures that are non-reactive and unobtrusive. And we wrapped up our discussion by talking about the 4 different scales of measurement: nominal, ordinal, interval, and ratio. As always, thank you very much for watching, and I will catch you next time on Research Done Right.